In this lab exercise, we are given a file containing a few C functions, one of which we need to complete. The purpose of this C file is to create a square BMP image of dimensions 512 pixels by 512 pixels. The output that we want to achieve is a chessboard pattern with 8 rows and 8 columns. In this case, the square tile is 64 pixels long. Luckily for us, we only need to complete the draw chessboard function. As we can see, draw chessboard is a void function, which means that it doesn't return any value. It does, however, take in a pixel array as input. Normally, when variables are accepted as a function argument, if the function changes the argument in any way, the changes don't persist in the calling function. For instance, the void doubler function here multiplies its argument from main function by 2. But when we print the same value we sent to the doubler function, it is still 5. This behavior is called pass by value. When arrays are passed to a function in C, they act differently to regular variables. If the called function changes the array, the changes will persist in the calling function. This behavior is called pass by reference, and it allows us to set the values of the pixels in the array in the draw chessboard function. We are given a two-dimensional array of pixels, which is basically an array containing other arrays within it, which contain pixel structs. As we can see from the type def above, the type pixel is defined to be a struct pixel, which contains 3 unsigned chars in it called red, green, and blue. In this case, the reason we use unsigned chars is because we want to hold a number which will be between 0 and 255. All we need is a single byte of memory to store this, so unsigned chars are more appropriately sized for this purpose than integers. The unsigned word just means that the variable can only take a positive or 0 value, not negative. The job of this function is simply to change the red, green, and blue values for each pixel in the array. The pixels should either be black or white, depending on their location. A black pixel does not contain any red, green, or blue light, so we set all 3 values to 0. A white pixel contains the maximum possible red, green, and blue light, so we set all 3 values to 255. Next thing I'll do in this function is to create 2 pixel variables, one black and one white, and initialize their values of red, green, and blue. Next I'll create a nested while loop. In order to iterate over a two-dimensional array, we need 2 while loops. In this case I'm using I and j as loop counter variables. I'll initialize both of them to 0 and then increment them once their while loop has finished. The inner while loop is executed multiple times, because it is inside another while loop. Between each execution, we need to remember to reset the loop counter j back to 0. Each loop should run 512 times for 512 columns and rows. We can conveniently use the hash-defined board size, which is defined further up in the file for this. Inside the inner while loop, we need to set each individual pixel to either black or white, depending on the pixel's location. I'm going to make a function called inBlackSquare, which takes in the I and j coordinates and determines whether the pixel should be black or white. If we make the function return either 0 or 1, which are considered false and true in C, we can plug the function directly into an if statement within our nested while loops. Using a well-named function in our if statement condition, especially when the condition is complex, is advantageous as it makes our code a lot easier to read. Inside our if statement blocks, if we are in a black square, I'll set pixels I, j to equal the pixel struct called black, and if we're in a white square, I'll set pixel I, j to equal the white pixel struct. Lastly, we just need to complete our isBlackSquare. Firstly, I'm going to set up some hash defines for true and false to be 1 and 0 respectively. This will make our code easier to read within this function. I want somewhere to be able to know which square the pixel is in. We can calculate the number of the square from our I and j coordinates. If we divide both of them by 64, which in this case is hash defined as square size, C will truncate the fractional part, meaning the result will be an int with no fractional part in the range of 0 to 7. Now we just need to find some mathematical correlation between those square coordinates and whether they are black or not. Looking at the sample image in the lab spec, and remembering that the bottom left square is coordinate 0, 0, you may notice that every time the square coordinates are both even, such as 0, 0 or 2, 4, the square is black. Also, if the coordinates are both odd, such as 1, 3, the square is also black. In general, if both of the square coordinates have the same modulus of 2, they are either both even or both odd, but in both cases they are black. Going back to our code now, if the x square modulus 2 is equal to the y square modulus 2, the square should be black, and so we should return true. Otherwise we return false. Let's compile our code and run it with /chessboard greater than chessboard.bmp. This will create a BMP image file. As we can see, we are outputting a valid chessboard image, so let's use the autotest. Let's review. Basically, the only responsibility of the draw chessboard function is to assign the correct values to the array called pixels. We use the nested while loop to iterate over the array itself and set each pixel to either white or black, depending on the location of the pixel itself. This decision is made by the isBlackSquare function, which returns true if the coordinates of the square itself are either both even or both odd.